Allosteric enzyme curve for alpha-ketoglutarate dehydrogenase. In the presence of high AMP, high succinyl-CoA, and no regulators. In comparison to a basic enzyme kinetics graph, which follows a more hyperbolic curve, like so, we will instead follow an allosteric enzyme curve, also known as a Michaelis-Menten curve, which takes a more sigmoidal shape. Our x and y axes should have substrate concentration. On the x-axis, represented by S with brackets around it, and our y-axis should have the rate of reaction, which we will illustrate as a. Now we will draw the sigmoidal curve representing the enzyme in the presence of our substrate. This first line will be our enzyme in the presence of no regulators, so it's just natural. And we will follow it by drawing it in the presence of high succinyl-CoA, where in this case it's going to be a negative regulator. Oh. This is a negative regulator. And we'll write it out here. And finally, we will draw it in the presence of a positive regulator. These all should have the same Vmax, so they all reach the highest point on the y-axis at an equal value. Let us not forget to label our high AMP. And talking about the Vmax, we might as well put that down. This plateau at the Vmax occurs in all three at the same point because this is when the enzyme is saturated, meaning that all the available enzyme molecules are processing the substrates, which is also known as Vmax for maximum velocity. Now with Vmax, you could also find the half Vmax, which will in turn give us the Km of the alpha-ketoglutarate dehydrogenase. And our half Vmax should be around here. Our half Vmax is going to be used to find our Km value, and that could be used by tracing down from the half Vmax to x-axis. And the Km value is the measure of the enzyme's affinity towards a certain substrate.